You're listening to the Cyberwire Network, powered by N2K.
This episode is brought to you by Palo Alto Networks, the leader in cybersecurity. As AI-driven attacks increase, organizations can't afford to have network security that's stuck in the past. Discover how Palo Alto Networks can help you predict what's coming and proactively secure against it with a zero-trust, AI-powered network security platform built to secure whatever, whenever, wherever. To learn more, visit paloaltonetworks.com/network security platform. Hello, everyone, and welcome to the CyberWire's Research Saturday. I'm Dave Bittner, and this is our weekly conversation with researchers and analysts tracking down the threats and vulnerabilities, solving some of the hard problems, and protecting ourselves in a rapidly evolving cyberspace. Thanks for joining us.
So as part of our work, we do routine analysis of customers' environments related to how non-human identities are connected to their environments, and specifically in the Google Workspace environment. And we saw something a bit odd.
That's Tal Skverer, research team lead at Astrix Security. Today we're discussing their work, GhostToken, exploiting GCP application infrastructure to create invisible, unremovable Trojan app on Google accounts.
Saw an app whose name was changed from, we usually see apps that have like this readable names, like Google Drive for work, stuff like that. But in this case, we saw an app whose name was identical to its identifier, which is just like a chain of random letters. So when we dived a little more deeper into that, we speculated that this happens if the developer of the app deletes the app. And then the backend at Google gets confused and doesn't know where to take the name from. And when we looked a little more deeper into that, we found out that when you create an app in Google, it's actually contained within a project in Google Cloud Platform, which is the cloud infrastructure that Google provides. And then we went ahead and created our own app within some project in GCP. And when we deleted the app itself, then the same thing happened. The name of the app became its unique identifier. But then we wondered what would happen if we deleted the entire project instead of just deleting the app. And when we deleted the project, actually the same thing happened. So the name of the app was identical to its ID. But in GCP, they have this nice feature that because a project usually contains a large amount of data that may be important, they give you 30 days to regret your decision to delete the app, to delete the project, and it's important. And you can restore the project to its original state. And we noticed that when the project is deleted, it's actually not really deleted. It's like in a pending deletion state, some kind of a limbo state. And during this time, all the users that install the app that is contained within the project in GCP, they cannot see the app in the management page. So every user who installed maybe, tens of apps can see all the apps and the permissions that they gave them in a single page. And if the project that belonged to some app is deleted or pending deletion, then they cannot see the app. But we noticed that if we decide to restore the project before 30 days have passed, then all the original tokens, which is basically the unique password given by Google to the app that the app can use to access the user's data, they start working again. So the whole attack scenario was pretty clear at this point. Let's say that a victim installs an attacker's app. Immediately when the victim does that, the attacker can immediately delete the project that is associated with the app, because the attacker controls this project. Once they do this, the victim cannot remove this app anymore because it's removed from the management page. But the attacker at any time can restore the app, quickly access the victim's data, and then delete the project again so the app returns to this pending deletion state. And this can go on forever because every time you restore and delete the project, the 30 days, they start again, they refresh.
So just so I'm clear here, I'm a user. I download and install a Google app, and it turns out that app is malicious. And in installing that app, I have to grant that app permissions to access various things in my Google environment. Could be my email, could be my files, whatever. And so what you're saying is that what you've discovered here is that the bad actor, if I go ahead and install a malicious app, this mechanism allows the bad actors to basically disappear for a while and then pop back up, grab some data, and then disappear for a while. And they could do that forever, and chances are I would not know.
Exactly. Yeah, that's exactly right.
The start of the year is a great time to take that next step in your education, career, and beyond. Rely on N2K certification prep to provide the tools to help boost knowledge, skills, and confidence to get you there. And now, for a limited time, all N2K certification practice tests are 40% off. Visit n2k.com/certify and use promo code N2KVDAY. That's N2KVDAY to save 40% on your purchase. That's n2k.com/certify with promo code N2KVDAY. Offer ends Monday, February 19th. Happy learning.
And now a word from our sponsor, 6sense. 6sense provides award-winning cloud-based automated endpoint and vulnerability management solutions to streamline IT and security operations. With its advanced platform, businesses gain complete visibility and control over their infrastructure, reducing IT and security risks and optimizing operational efficiency. With 6sense, you'll get real-time alerts, risk-based vulnerability prioritization and remediations, and an intuitive automation and orchestration engine so you can focus on your core business goals, confident in the knowledge that your enterprise is secure, compliant, and running smoothly. Visit 6sense.com to learn why enterprises choose them. And so what is going on under the hood with Google that allowed this to happen?
Okay, so I guess you can call this hindsight, but after the fact, and when I prepared my talk in the upcoming DEF CON, I wondered what happened that this scenario even happened in the first place. And it led me to dive deep into the protocol called OAuth. It's an authorization protocol released about a decade ago that basically powers this whole interaction between users, developers who have apps, and Google. And when I looked into this protocol, I noticed that while it really gives a good outline of how the protocol is supposed to work, it ignores two very crucial things that basically allow this GhostToken vulnerability to exist in the first place. The first thing is the question of what happens when you need to register an app. So the original standard for OAuth doesn't really deal with that. It leaves a lot of information to be decided by Google in this case. In this instance, Google decided to include app registration within GCP, which actually caused this whole, project deletion, pending deletion, and restore scenario. And the second part that was missing from the original protocol is what happens in the user management page. Because if Google would have allowed, a more thorough audit log of all accesses done by any apps to your account, this whole vulnerability would be irrelevant because you will be able to see any access done by apps to your account. So the attacker couldn't have hidden their app from the user. So these two missing pieces were actually the big reason that the vulnerability existed in the first place.
And so you reached out to Google here to let them know, and they've been responsive?
Yeah, so actually they were really responsive at the beginning, and I think about 2 months after I submitted it, I got the famous nice catch, and they started working on the fix, but apparently it wasn't that easy to fix. Like the origin of the vulnerability came from deep infrastructure of Google. It has to do with how projects work in GCP and how apps within project works and what they display to users and how they handle tokens. And I guess this was one of the reasons that caused Google to take a lot of time before they found a good fix for it. And during this process, they were quite responsive. They were talking to me and we were trying to understand best what's the good way to solve this issue.
And so ultimately, what happened?
So at the end, they decided to, let's say, fix the issue by letting the users still see apps that have been deleted. They didn't fix the issue. They didn't see an issue in the fact that a project enters a pending deletion state and you're able to restore it. This works as intended. So they just change it so users can see apps that belong to projects that are pending deletion.
Is there any evidence that anyone had been making use of this functionality?
Yeah, that's an excellent question. I've been really wanting to know if it's correct or not, if it's true or not. But it's very difficult to find out. And the reason is that even if you are, let's say, an administrator in your Google Workspace organization, then you have more extensive audit logs about accesses done by apps. But the problem is that when you try to find out in hindsight if someone exploited this vulnerability, then all the accesses from this kind of apps would look just like any other app, because when the attacker restores the project associated with the app and then access the user's data, then it looks like just another normal log of an app who has a correct name. The name issue is fixed when you restore the app. So there is basically no good way to find out if anyone abused this. I'll also add that the problem is that deleting apps happen naturally statistically in several cases. We see it in environments that we work on. So this makes it even harder because let's say you found an app who accessed your user data that is now deleted. You don't know if someone exploited the GhostToken vulnerability, or maybe the developer of the app decided to quit and delete their app. It happens.
So what are your recommendations then for folks who think that this may be a concern? What can they do?
My first recommendation for people who are afraid of that is basically start by monitoring you have a special page as a Google user where you can see all apps that have access to your account and their permissions. So start monitoring that and remove any app that you don't trust their developer enough with your Google data. I recently found out that my TV has full access to my Google account for some reason. Yeah. So this is basically my recommendation for regular Google consumers, and anyone who is an admin of a Google Workspace account, I recommend making restrictions on new apps that your users can add. For instance, there is a nice policy in Google Workspace that allows you to say any new apps that my users are going to install themselves will be unable to access their Drive or their Gmail, which are the most sensitive services in Google.
Our thanks to Tal Skverer from Astrix Security for joining us. The research is titled GhostToken, Exploiting GCP Application Infrastructure to Create Invisible, Unremovable Trojan App on Google Accounts. We'll have a link in the show notes. And now, a word from our sponsor, SpyCloud, the cybercrime analytics leader. SpyCloud disrupts cybercrime by telling you what criminals know about your business and your customers, so you can take action to prevent ransomware, session hijacking, account takeover, and online fraud. SpyCloud constantly recaptures and analyzes new data from the criminal underground, including credentials, session cookies, and PII siphoned from malware-infected devices. With knowledge of the specific exposed data criminals have in hand from InfoStealer malware on managed and unmanaged devices, security teams can respond with a more efficient and effective process called post-infection remediation that fits seamlessly into existing incident response frameworks. Get SpyCloud's post-infection remediation guide outlining the 7 steps for preventing a malware infection from becoming a full-blown ransomware incident. Visit spycloud.com/cyberwire. That's spycloud.com/cyberwire. And we thank SpyCloud for sponsoring our show. The CyberWire Research Saturday podcast is a production of N2K Networks, proudly produced in Maryland out of the startup studios of Data Tribe, where they're co-building the next generation of cybersecurity teams and technologies. This episode was produced by Liz Irvin and senior producer Jennifer Iben. Our mixer is Elliot Peltzman, our executive editor is Peter Kilpie, and I'm Dave Bittner. Thanks for listening.